The idea of this short talk here is about what motivated the topics for this workflows community summit. Of course, a lot has been happening lately during these past years. Uh, some of us, we got together and we decided to do let's write a paper about what we think are the predictions, technology predictions that are going to happen in scientific workflows in a few years. So basically, if you look at the evolving landscape of the scientific discovery today, it's becoming very, very complex. So if you look at the data explosion that happened, data is everywhere. It's been generated at very fast pace, and people are having issues to move the data, to stream the data, and so on. And combined into that, we have all this AI revolution that it's every single day it's a different thing. You learn something on AI today, tomorrow it's already different, and you try to apply some techniques. It's cool, and then there's something better already. So all of these, it's making the work much harder, and workflows is becoming even more prominent. Like we keep hearing people talking more and more about workflows or different similar names that are it's helping them to structure and automate the processes. So we start seeing the situation that workflows is not running into a single facility anymore. So now they are combining different computational facilities, observational, experimental facilities with computational facilities. And this, as you can imagine, is become even harder now to structure and organize these the need for the workflows. And of course, when you talk about this, we bring to heterogeneous environments. So on the heterogeneous side, and when you go to each computational facility, experimental facility, they have different set software stack, hardware. If you look at the policies are different. So in this case here, for example, let's look at an experimental facility that has some edge computing, and then we have a computational facility with HPC, and you have the cloud outside. So how we can connect all of these things together with these the noise that seamlessly to the user, that the user doesn't need to understand every single parameter that it's available there. So interfaces here, user experience is extremely important. As we mentioned, with this data explosion, there is this new real-time data analysis that has become more and more prominent, especially with AI. So how you can transfer quickly, stream data into an HPC system on a cloud, do some, for example, ML model training, and then use the inference back to steer the experiment. And so it changes the requirements that are before you would have too many static workflows, but now the workflows are becoming more and more dynamic. You have the human in the loop aspect, so how the user is influencing also that decision on say, oh, this model is providing something that is accurate enough for me, or it's not good enough, and I might want to change the way I'm doing my entire experiment. And of course, all of this comes with sustainability challenges that I'm going to talk a little bit more later. So on this figure on the right, and it's also on the paper, we try to capture all of these the answers of all of these things together. So when you talk about AI HPC, the synergy between them really is trying to how we can amplify these scientific capabilities. So simulation was always complex, but now we are also having providing data analytics, and everything now. If you look into the new AI world, everything is about data. So how we can be, ensuring that all the AI solutions, models, and so on that has been developed today is working well with HPC. And for that, we start making a few predictions, and we believe that, for example, in the future, we're going to have AI-powered HPC workflows that is going to enhance the efficiency by orders of magnitude. Actually, it already has. We have works that we're going to hear today, during the presentations and the breakouts. But we believe that we can go even further on that. So we know that all the HPC data sets that has been generated are being extremely useful, and we're going to keep increasing the size of the generation of this data because AI needs data. So the way we can make sure that we are training the next models and so on, we need to have more data. And we believe that it's something that it's going to happen, but of course, you're going to have to deal with all this data. That it's another problem. Also, as I mentioned before, to know how AI can dynamically steer the simulation. So we believe that we're going to see more and more digital twins, comprehensive twins around, helping to understand how an instrument or a resource works, and help take quick decisions to better understand and steer your simulation and so on. And also having the LLMs trying to have a better conversation with the researchers too. On the multi-facility collaboration side, of course, as I mentioned before, we talked about how we integrate these different facilities with different hardware, software stacks, and so on. And some of the predictions we're trying to do is, well, we're still going to have, we're going to have AI, systems there that can help orchestrate this complex multi-facility data processing. We believe, that standards are important, and defining standards, we know that it's hard. It's not the easiest thing to do. So we might not only call maybe standards, but having specifications and how we could, have different implementations of the same specifications that would make it easier to collaborate. So there is no friction when you are, working on one facility or another, but at least they try to speak similar languages. And we believe also that we're going to start having more standardized data stream frameworks that can enable these multi-facility workflows. Because if you look at today, there are several data streaming solutions, but we still don't have a common way to use this data streaming across all the other places. So data-driven dynamics, as we mentioned before, everything now it's about data. We are generating a lot of data, and we need more and more data. But this becomes with a problem that, okay, we have this huge amount of data, but how are we going to handle that? So we need to have these adapted workflows, that are processing data on near real time through the streamings and so on. But we believe that in the future, we need to have somehow, a dynamic near real time way to control this data, to have a data plane, into the workflow side that would become the norm. More importantly than the control plane that we spent so many years doing research on that, now we need to look more into the data plane side. Of course, as data grows, we need to look into data reduction techniques. And so it's the only way, that we can quickly stream data to another place or transfer data to another place in smaller scales, and we're not going to flood the network with that. And as I just mentioned, also these service-oriented data planes to abstract the complexity, and then we can have more flexibility. So we're going to have our goal. We believe that in a few years, we already started, but we're going to be much better looking into the workflows with the data perspective and more the control perspective as before. And there is the training of this. When we talk about different facilities, I talk about different hardware. And there is heterogeneity now. Before, you would have a workflow that would run either on an HPC system or in a cloud system, or edge appeared, and we would be working on different things at a time. Now we need to combine all of them together. And it's not talking only about HPC, cloud, and edge, but look at the accelerators. We have more and more AI solutions today. There are very accelerators that are very optimized to perform some kind of AI operation. So how we incorporate them into the workflows. We're talking a lot today about quantum. So quantum computing is becoming a reality. There are controversies on that. This is not the topic for discussion on this summit, but also how we might consider quantum in the future. How we're going to consider these systems, and it's heterogeneous. It's different from what we are used to do today. So some of the predictions we see, it's the specialized hardware, including the accelerators, and it's going to reshape the entire HPC architecture. So we need to be paying attention on that. We look into the novel software solutions, guaranteeing performance across these different systems. And we need to look into the portability aspect of it. So when you move to one system to another, you don't. It's very painful today for the researchers to have to recalibrate, to re-optimize the entire solution to that new system. So there is something that I believe is going to be also be discussed on the topics of this summit about this portability layer. And another prediction is, the integration of Edge and HPC, that we can make a more fluid computing continuum. And last and not least, we talk about all of these, beauties. However, we know that these things are expensive. So if these things are expensive now, how we can make the most sustainable HPC practice in this case? So, when you talk about AI, there are several publications that show the cost of AI with energy. We see the cost of energy for the supercomputers. So energy efficiency has become a huge topic. So we hope that is one of predictions that we're going to manage to evolve AI and ML to optimize these workflows for maximum energy efficiency, and also create new sustainability benchmarks that can drive this eco-friendly HPC practice. We have several benchmarks today for specific systems. We are getting to the era now. I think we are having a few of workflow benchmarks that it's great, but also we need to start thinking about these sustainability benchmarks. And to enable all of that, we believe that having provenance systems that can track detailed information about this environment footprint is essential, so we can better understand the impact of these applications, these new technologies, and the new solutions we are going to develop. So with that, and I'm glad I'm just on time, I'd like to thank you for listening. If you want to learn more, there is a paper that has been published last month, and I can drop the link later in the chat if you need, if you're interested in that.